Yeah, so in part two, let's discuss about the cloud environment, right? Like we just cover in the part one that how the on-premise architecture looks for the single sign-on, and in this, like we'll discuss about the cloud part. In cloud, basically, like we'll just cover the AWS part, right? In other cloud also, like whether Azure or GCP, things will be same, but the naming convention and few other functionalities will change, but the logic and the scenario will almost same, right, in any of the cloud. So we'll just try to understand the AWS. Like I already open app.diagrams.net, so we'll just try to draw something to understand, and it will basically the same like what we have seen in the on-premise. But yeah, as I told that in the AWS environment, you are getting the functionalities. You are getting like I can say it is easy to configure that as compared to the on-premise, right? So you will get everything in a single place. You're just need to use those things, and then you can just develop your architect for the single sign-on, right? And then you can use that. Whereas in on-premise, yeah, you need to just see how the things are running, and the other you just need to just set up different teams and set up different altogether environments, right? Like network, firewall, Windows, Unix, and other things, right? And then you can just install your product, and then you can just configure this to basically that run the single sign-on. So yeah, let's try to understand this. It's again the AWS model, because right, PingFederate is like is the product where we need to install and configure. So it will just run under the AWS model of the cloud, that is infrastructure as a service. So yeah, let's try to understand quickly so that you can get to know the differences and all. So yeah, let's quickly draw. Yeah, so we'll just pick this as similar what we did in on-premise. Okay, same thing I'm doing here also. So just a AWS environment. So yeah, you can see there are a few differences, but yeah, the things will be same only. So internet users, so I'll just make I need to draw again, like for both the flow, right? If a user is accessing the application from internet, or if the user is accessing the application from intranet, then how the flow is going to change. So I just need to draw both of the flow as I shown you in the on-premise. Yeah. So first of all, the traffic will go to in a similar way what we have seen in the on-premise, just like here also. It will go to, let me put it like this. Yeah, it will go to where? Public DNS, right? Okay. Now from public DNS, like we have something here. Okay, we have here firewall to basically stop the unmalicious, unauthentic traffic. You need to know about the SQL injector, and there are many firewall predefined rules. So you can use those and just stop the unmalicious or unauthentic requests, I can say. Okay, so this is a firewall. Once you cross that layer, then you will go to PHS. I just told you on that day, right? Public hosted zone. So let me first draw, then I'll tell you what is that. So I'll make something as a container. Okay, let us bring this. This is PHS. Okay, this is public hosted zone. That is basically, what is this public hosted zone? It's basically the container, okay, that holds information about how you want to route traffic on the internet for a specific domain, right? Like whatever example, like for example, right, that example.com, then we have the subdomain of that, like acme.example.com, right? So domain is example.com, then that subdomain will be abc.example.com, like that. So it's a container, right, which holds the information that how you want to route the traffic on the internet for a specific domain. That is the use of PHS, public hosted zone. Right, we haven't seen this in our on-premise, right? In the on-premise, we have something we are using as a global traffic manager, right? So yeah, I discussed you in that discussion also, right? I just talked to you about PHS. So this is PHS. Now once you complete like from here, Once you user come here, now user will go where? User will go to, let me draw like this. Sorry. So okay, yeah, so I'll just draw now. You can understand right now, right? You have just gone through the on-premise. So once we cross the PHS, what thing will come here? It will be the load balancer, right? The external one. In AWS we can say is as a ELB, right? Elastic Load Balancer. So let's make it like that. So let's bring some load balancer. So now here you are not supposed to go and search for firewall outside of your environment, right? Because you are getting everything in the AWS only, right? So you just need to start using those. Let me do it like this. Okay. This is our load balancer. Okay, I'll say make it as a public ELB. Okay. Public Elastic Load Balancer. Okay, we are saying this. Basically, it just get the traffic from the external environment, right? From the internet, as you can see. Now, once the request reaches here, now what will happen? Let me bring it that. Yeah. So. I'll draw another one here. So again, like for the high availability, we just need to do the same thing, right? What we did there. So yeah. So now when the request is coming from the ELB, then again, like as whether it's ping access or Apache, anything you have which is acting as a reverse proxy. So we'll say this as a, like I'll bring it right. I'll just make some small boxes. Okay. Let's bring. Not like this, right? It's too small. Okay, I'll put it here. One. Put it here, another one. So you have multiple nodes, right? As to help the as to just handle the load. Yes, it depends on your infrastructure, right? Like how big your infra, right? If it's too small, then you're not supposed to go for the multiple nodes, right? Because you're the less number of nodes can able to handle the traffic, so I need to increase those. Yeah, so we have as a high availability environment, we just need to keep our service on two different data centers, right? Take an example as we told in the on-premise, like Chennai and Bangalore. So here we have the cloud, so we can say as a zone A and zone B. So I'll make it as a BC zone A, data center zone A. Okay, and another one we can say as a DC zone B, right? So we have the server here, so I'll tell this as a reverse proxy server. Okay, so RP A, we can say as a A1. Sorry, what happened? RP A1. Okay, and we can say this as a RP A2, reverse proxy A1, reverse proxy A2. Then we have reverse proxy B1, reverse proxy B2. Okay, so we have the data center zone A, zone B, and we have the reverse proxy. So the traffic will go as per your reason. It will go to the data center zone A or data center zone B, and then as you have configured whatever the rule in that server, it will just perform. It's just extra layer of security, right? And from there again, now the traffic will go to where? To your another load balancer that we called as a ALB, right? So yeah, let me complete this and I'll just show you a few more things here. So let me just first draw the load balancer. Where is that? Yeah. Yeah, so we have now the another load balancer, that is a application load balancer. Okay, let's mention this as a private ALB. Okay, private application load balancer. So let me just complete the traffic to PingFed, then I'll just show you a few more things here to understand about network something. Okay, so let me just quickly complete this. So after private ALB, you know what will happen. The traffic will move to where? Let me draw that again. Let me draw like this. 1 second. I'll make something as an arrow. 1 second. I'll take this, or I'll take a manual. Yeah, this will be fine. Okay. Yeah, so you have one, make it another. Sorry. Okay, so we have again two data centers, so zone A, zone B. So I'm just trying to draw here now PingFederate, so let me put it like this. Okay, again here you have multiple nodes, right, in this data center, so I'll make it one. Okay, like you can have a multiple nodes, right? Depends on your traffic, depends on your load. This box is, you can consider this box as a virtual machine. Okay, virtual machine 1, virtual machine 2, like that. Okay, let me make it a little small. Yeah, so this is your PingFederate. So this will say as a PF zone A, so PF A1, PF A2. That means this is the server where your PingFed is running, right? And that server, the reverse proxy, is where your Apache service or any kind of ping access another service is running, which is just creating extra layer of security and yeah, exposing, and you're just help securing your PingFederate, right? Here your PingFed is not exposed over to the internet, but your reverse proxy server is exposed over to the internet. Okay, so PF B1, PF B2. Okay. Okay, now let's understand one thing here. Okay, so we just reached to the PingFederate, right? Now I'll just draw and show you that directories, the directory services, how it is configured and all, right? What we understand, yeah, like yeah, in the on-premise thing, the same thing will again come, because you are right now in the AWS, but you came now, right now you reached to the PingFederate under the AWS environment only. Your authentication is now going to complete. For that, like PingFed has to connect to some other directory services, right? Like I'll draw that Active Directory. Okay, so you have some multiple, like Active Directory, you have databases, you have other sources, right? You have the MFA, like multi-factor authentication, right? These are multiple things. So your basically PingFed engine has to connect, right, to these all sources. Sorry, what happened? Yeah, the diagram looks a little bit funny, but yeah, that's fine. Okay, just try to understand. So this is basically for both the data set. I'm just trying to draw you, right? So basically PingFed has to connect to this backend sources to basically handle your authentication, because as I told, right, PingFed is not keeping the user information. So for your authentication, PingFed has to connect to directory where user information is stored, right? And again, PingFed has to connect to directory to fetch the user information for generating the token, right? Access token, ID token, or sample token, any kind of token, and then it can send to the application where exactly user get authorized to access an application. Now see here, right? So this is a kind of directories, right? You can have a AWS directory also, but depends like whether you are using that directory or not. Okay, so now this is like the internet traffic. I'll just quickly describe you about the internet also. Internet, I think you understand right now, right? It's not going to make more changes. It's just the user will go to the private DNS instead of public, and then it will just directly reach to the private ALB, and then how the traffic will go, it will just work like that only. What I'm just trying to show you that you can see, right, your reverse proxy server is in one type of subnet, in one type of network that we can say as a DMZ subnet, right? So what is this? Like, let me first draw this with some arrow mark. Yeah, wait. Okay, so let me draw for this also, but maybe it can be understood, right? The similar way we have for the DC zone B also. So this is where this is basically is present in DMZ subnet. What is this? I'll just tell you. DMZ subnet, that means the place where your reverse proxy server is installed. That means you have some server, whether Windows or Linux, and your some service is running here, which basically just play a role in the single sign-on traffic. That means the outside, like the traffic is coming from the internet, it has to go through this reverse proxy server, and then finally going to reach to PingFederate, where exactly your authentication is going to handle, right? So this DMZ subnet is nothing but what is this exactly? This is just like basically it's a demilitarized zone network. Basically it's called as a, maybe you can just Google it also, you can get more information for this, but as for basic understanding, it's a demilitarized zone network, or we can say as a DMZ. It's a logical subnet that creates an extra layer of protection from external attack. That means you can see your reverse proxy server is basically exposed over to the internet. That means internet traffic is directly hitting to this, right, from public elastic load balancer. So that's why we just place this under DMZ subnet, which basically just a kind of logical subnet which creates an extra layer of protection from external attack. So basically you have a firewall also which basically stops, you have a DMZ subnet also which basically creates an extra layer of protection from the external attack. That means if any unmalicious request or any kind of unauthentic request or any kind of anything is going to happen from external area, maybe any kind of malware type of attack or any kind of thing, right? So it can just stop that, right? Because it's just creating extra layer of protection from external attack. So it's a kind of logical subnet, right, that basically creates an extra layer of protection from external attack. Now you can see you have another PingFederate. So you can just ask that where exactly our PingFed, which subnet, which network our PingFed is present, right? So let me draw that also. So yeah, this is the engine node. Okay, as I told you, engine node also connects to the admin node. Maybe I just draw that also. Yeah. Sorry. Okay, so maybe I can just show you something like that. Wait. So your PingFederate, this is PingFed engine node, okay, and this is basically connects to the admin node also using some port, right? So you have the admin node also here. I'll say as a PingFederate admin node. Admin node is just like administrative node, right? So in the next session, next to next, we'll just install and you can see that more on that. So basically we just handle the administrative work, right? You can just go and do something, right? You can just create the policy, you can just onboard the application for single sign-on, and you can just do something, whatever in the PingFederate, right? So and in the runtime, this engine node is called as an engine node, which basically just handle the authentication request coming from the internet or the intranet. All right. So yeah, what we are trying to understand, yeah, where our PingFederate is reside, right? So let me first draw this. Okay, so this is present in one network, and that network is called as a, I'll put it as a, right, I'll keep it here, okay, that is called as a private subnet. What is this private subnet? You understand about DMZ, right? It's just a net logical subnet, right, which basically just create an extra layer of protection from external attack. What is this private subnet? So private subnet is basically, it's again a network only, which does not allow access to the internet. That means from internet you can't reside to this network, you can't come to the private subnet, right? So basically it's just, you can understand in a one line, it is not allowing access to the internet, that is, it is not allowing the traffic to reach to this area, right? For example, if any request is coming from this area to this to the private ALB, now if it reaches to this place, it's not going to allow, because this request is from internet, right? It's not going to allow that internet request. That's the meaning of simple private subnet. Now your next question will come, then you can ask to me, then how a internet user can able to access SSO based application if that application is a SaaS. That means if it is already exposed over to the internet, then how a user can able to access that application using single sign-on, because you are saying that your PingFed is reside under private subnet, and private subnet means it's not allowing access to the internet. Then how it is going to happen? So now there is a thing, right? I told you in the on-premise thing also that something called as a NAT, right? Network Address Translational Process. So that is a NAT process, right? I'll mention this here also. Maybe you can just go through this thing, you will get more idea. I'm not a network expert guy, so I'm not able to give you more information about that. But yeah, it's a network address translational, right? It's a process through that the traffic can reside from the internet to your private subnet area, right? And then your exactly user gets authenticated if the user is coming from the internet traffic also. That's a kind of thing, right? So you have private subnet, DMZ, right? And then you have this is the, yeah, and you have this flow, right? So basically in general, as I told in the on-premise also, you have seen same thing, but here you can see there are few things coming. I will not say coming, it's just like AWS is just giving you everything, you're just utilizing. That means you have AWS already giving you the public ELB, private ALB, it's already giving you the virtual machines where you install your services, whether it's a reverse Apache or whether it's a PingFederate. AWS is giving again you the firewall, it's giving you the public hosted zone for the traffic routing part, right? Everything it's giving by them only. You're just utilizing that and building your platform, right? Building your application or whatever the service you're building, single sign-on in this case basically, right? Okay, so this is thing. Now if I can say for the intranet, nothing is going to change, right? I think you all know right now, so you are now comfortable to understand this architect, right? I hope so. So let me put it like intranet, okay? Intranet users, okay? So intranet users, where the traffic will go, same thing. So sorry, So first the traffic will go where? It has to go to some DNS, right? In this case it will go to where? Private DNS, correct? And from private DNS, once the request reaches the private DNS, then you have a flow through which you are basically directly hitting to the private application load balancer server, as we have seen in the on-premise, right? So in the similar way, you are from private ALB, you are directly hitting to the private application load balancer server, and then how the request is flowing, it will flow in the similar manner. Now here I'm not drawing everything, right? I'm not drawing the network devices, I'm not drawing the firewall, I'm just giving you a rough idea. But if I talk about, like you can see from PingFederate to MFA, right? You can see this looks very simple, right? That means traffic can simply reaches to the PingFederate engine node, and then from there, for the multi-factor authentication, you just connect to the some multi-factor product, like whether it's a ping ID or DO or any other product. But between this to this, between point A to point B, there are many network devices and the firewall placed here. Okay, so I'm not drawing that because whenever you are just moving from one path to another path, you need to think about network, you need to think about firewall, because you need to think about the network security perspective also, right? Because you are just giving a security to the applications, right? A kind of security, right? You are providing a single sign-on to the applications, which basically just allow them to access an application without kind of authentication prompt and a safe with seamlessly and a safe with a safely, right? Without any problem, right? Without any without any what I can say, without any thing for the security part, right? Like without any thinking for the security thing, that whether there is any breach or anything, you're simply just accessing the application safely, seamlessly, without any issue. So when you're designing your architect, you just need to think everything, right? About everything, right? About the network thing, firewall thing, about the network path, about your product, exactly where it's running, right? Everything I can say. So that's why I'm saying I haven't drawn everything here, but I just give you a rough idea which will help you to understand. In general, this is our architect building happening in general, right? Then you in the AWS you can get multiple like health checks, monitoring, right? Which basically just checks the server health, right? So what is the health check here required? So you can see that when the traffic is reaching to the public elastic load balancer sends a request to different nodes, right? In data center zone A, it can send the request to reverse proxy A1 or reverse proxy A2 in the similar way for the DC zone B also. So I just need to see that whether the health of this server is good or not, and the service, right? Server health is definitely required, and the service, that means Apache service is running here, so whether my Apache service is fine or not, right? So here we have in the AWS we have the health check, which continuously monitor the health of these services, right? For A1, A2, B1, B2, and if the health of anyone is not looks good, it can stop sending the traffic to that node for some particular time, right? And it can just send you alarm also, right? So you can also go and manually check that. So these all facilities you are getting easily in the cloud environment, but you'll not see in the on-premise. Okay, yeah, I'll mention this as a AWS. This is a AWS environment, okay? Example of AWS. Okay, so now you can just make these things by your own also, right? In the lab we can see this, right, in the lab, but maybe I'm not able to draw everything, right, in the lab, because I'm just focusing more on the PingFederate part, not on the databases or not on the multi-factor. I just try to show you the multi-factor authentication part also, but let's see what are the things we are going to cover, right? And then you have this all things. So it looks fine. And so you need to put a health check for all this reverse proxy services, PingFederate services. Your load balancer health also has to be correct, right? Your certificate, all the things has to be monitored, so that in case if the certificate expired, it will just break the communication, right? So all these things looks very simple, right? But it needs many things we need to do here, right, to make the things ready. In the industry, maybe in the lab, maybe you can skip many of the things because you are not building anything for the industry, you are just building something for your learning. But when you work for any company, any industry, you just need to think everything, right? Because you're not supposed to skip any one thing, right? Because it can just make the security breach or make many problems, right? So I hope you understand this. So maybe just go through this part 1 on-premise, part 2 you have the cloud. And now in the PF0 So I think 8, right? So I'll just try to cover today, so we can just see about how to request for PingFederate developer license. So I just show you that like how you can create your account and then just request for the developer license that is valid for 30 days. You can get from Ping Identity for PingFederate product, and then PF09 will just set up the virtual machines in Google Cloud. So maybe you all have, I think, credit card. So using that, we'll just get a free Google Cloud services for some time. It's not Google Cloud is going to give you the free services for each entire thing, but few of their services are free. So we are going to get that for some time, like maybe 3 months. I think they are giving some credit. Same, I think, for Azure and AWS also, they have also some free trials, right? So you can use that also, but I'm just preferring Google Cloud here. So just create an account and just use the free trial and using our credit card, and then we are going to set up the virtual machines. Like we'll just take one Windows server, one Linux server. In the window, we'll just install PingFederate admin console. That means PingFed is going to run as a cluster console there. And on the Linux machine, we'll just put our PingFederate as a clustered engine. Okay. So yeah, we are going to do this, and then we'll just go for the PF11, that configuration of federation servers, and then we can start with the directory servers, right? And then everything is done, then we can quickly jump to the PingFederate and then go with the data store, password, credential validator, adapter, authenticator, selector, fragments, authentication policy, certificate management, and then we can talk about more and more, right? So thank you for this video. Let's connect to the next one. Thank you.